coming to the tech stack, we have used Flask, RabbitMQ, and Minikube. Flask is a Python-based backend web framework used for building REST APIs, and RabbitMQ is our messaging queue. And we have used Minikube for setting up a local Kubernetes environment. Coming to our project's architecture, we have publisher and subscriber running on localhost on different ports, and we have RabbitMQ running in Kubernetes pod. Both publisher and subscriber are configured to connect to RabbitMQ. The connection parameters are defined in both producer and consumer. So these are the Kubernetes objects. Here we have RabbitMQ, service, persistent volume, and persistent volume claims objects running in Kubernetes environment. We can see the same in terminal now. Persistent volumes and claims would provision the necessary storage resources for RabbitMQ pods to use within the Kubernetes environment. And we can also see here that the RabbitMQ pod is up and running. So here is our project repository structure and GitHub URL. Yeah, in producer.py, we have exchange name defined and publish endpoint and publish function defined. So for publish endpoint, we have defined post method. So when we make a post method to the publish endpoint, we can publish the messages to the RabbitMQ. The payload for this is going to be message and topic. For topic, we have two allowed topics, that is internal and external. Coming to the broadcast function and broadcast endpoint, this function is used to broadcast messages to all users irrespective of their subscription. So the payload for this is going to be just an urgent message.
And moving on to the consumer, so here is the consumer code, and we have the subscription and unsubscription in both in the consumer file. And also talking about the algorithm, so the algorithm which we implemented here is concurrency and mutual exclusion. So whenever a new user joins in or basically subscribes, a, a thread is created for the user, and the thread keeps listening onto the queue to see if there are any new messages. Once any message is published into the queue, the thread reads that and it displays it. So with that, we were able to achieve concurrency. Multiple requests need not wait. Each request can run independently by using this dispatcher mechanism whenever a message comes. And also regarding the mutual exclusion algorithm, so we have multiple consumers here running concurrently, and whenever each of them try to subscribe or unsubscribe at a time, like at the same point of time, so we handle that scenario using mutex logs. Whenever both users are trying to subscribe, so we basically lock it, and then just one user will get access to it, and then once it is done, we'll unlock it. So this is used in both subscription and unsubscription. And this is the unsubscription API, and here is the locking mechanism for it.
Start producer and consumer first. Now both the servers are running and we are making a post request to subscribe endpoint, and we can see the success message here. Yeah, all the three users are subscribed to their respective topics. And you can see in the terminal that that the subscription is successful. And let's go to RabbitMQ UI. Yeah, we can see that queues with usernames are created. And also the queues are bound to the broadcast routing key automatically for all the three users.
So just now we have seen how users are subscribed to their respective topics. Now let's publish the data into the exchange so that users can get the messages of their interest. So right now we are publishing the external info. So this is basically connected to Greenhouse API, Jobs API, and with that we will be able to get that info. So this message is published successfully, and you can see all the job related info. We have optimized the response so that response is actually pretty big and has a lot of fields. We optimized all that and are displaying a short response, a useful response. And let's also publish the internal events. So these are our internal events, like on campus events. And and down here we can see all the internal events. So we can see internal events only for Shrikar and Chaitanya. Last year didn't subscribe for the internal events, so that's how selectively user is getting the events. And also the threads are looking on the respective queues and displaying it without having to request those again from the queues. And let's also see the broadcast. By default all the users are uh, bound to this broadcast channel, and this broadcast cannot be unsubscribed by the user. So this is a broadcast message for all the users, Shrikar, Lasya, and Chaitanya. So this is over here. And let's now see unsubscribing, how users can unsubscribe. So here we have unsubscribe for Chaitanya, who's unsubscribing for the internal topic. And So Chaitanya unsubscribed from the internal. So that's also unsubscribe Lasya from external. So Lasya is also unsubscribed from the uh, topic external. So now let's publish again and see how the info is. And only one user got this. And let's see for internal. So internal is a short response. We'll be able to understand clearly. So internal, you see only Shrika has info for internal. Chaitanya doesn't have it as he unsubscribed it. So here we have our unit tests here for the producer and consumer. So this is so we have three successful test cases for broadcast and fetch external data and publish. So in the same way we have for consumer as well, three test cases. So these are also running successfully. And apart from these, we have a comprehensive logging for all the steps, and users can get it using passing a verbose flag through which they can get a good logging. And moving on next, we also have integration with Locust, so using which we are doing load testing. So we have Locust over here. Let's see a Locust file once. What we did was whatever APIs we have, we integrated them with Locust, and then let's run Locust. And also before that, let's stop our consumer so that all the messages uh, published by Locust will be in our queue, and then we can consume them later. Let's go to Locust UI. So here is Locust UI, and let's pass 200 users and span rate like 3 at a time. So let's see what's happening. So yeah, as you see, all of them are piling up in the queue as there's no consumer. And right now the failure rate is increasing because no one's consuming it. Locust is treating them as a failure. And yeah, now just let's stop it and start consuming it. So as okay, also, right, before consuming, let's do one quick thing. Let's delete our pod in order to test our persistence. So right now, if you see, we have like 137 around some messages and these queues, right? So let's delete our pod first. So let's delete our pod. So we are using Kubernetes persistence. I mean, we created Kubernetes persistent volumes. So using which all the data is persisted here. And we are also using Kubernetes deployments and replica set, which make sure at any point in time we have one pod in running. So we deleted that. As soon as we deleted, we are able to, I mean, the Kubernetes created one for us. So right now we have a small issue with Kubernetes services. We are unable to connect to Kubernetes RabbitMQ services. As a workaround, we are using this port forwarding. So basically forwarding it to the Kubernetes, I mean, our application port here. So let's forward these both. And now once our new pod is up and running as we saw previously. So let's go to the UI and just reload this. So yeah, this is serving traffic from the new pod and we have all our messages back. Nothing is deleted. So let's start consuming these again. So as we have threads looking on these are simultaneously fetching all the messages and they got all the messages.